No country in China's neighborhood is a match against China in terms of military power. China's military buildup is a matchup against only one country, that is the United States.
China just launched a hypersonic glide vehicle so fast and unpredictable, it turned America's missile defense systems into expensive paperweights. What happens when a weapon travels at 5 times the speed of sound while zigzagging through the atmosphere to avoid interception? And how does a single test flight force the Pentagon to reconsider decades of missile defense strategy? Join us as we reveal why China's hypersonic breakthrough has defense analysts scrambling and America's top officials admitting they have no idea how to stop it. Section 1. The weapon that breaks the rules. China's DFZF hypersonic glide vehicle represents a fundamental shift in missile technology that renders traditional defense systems obsolete. Unlike conventional ballistic missiles that follow predictable parabolic trajectories, the DFZF maneuvers unpredictably through the atmosphere, making interception nearly impossible with current technology. The system works in 2 stages. First, the DF-17 medium-range ballistic missile launches the DFZF glide vehicle into the upper atmosphere using a solid-fueled rocket booster. This initial boost phase propels the weapon to hypersonic speeds between Mach 5 and Mach 10. Once the glide vehicle reaches optimal altitude, it separates from the booster and begins its terminal phase. During the glide phase, the DFZF behaves unlike any previous weapon. Instead of following a ballistic arc that missile defense systems can predict and track, it performs evasive maneuvers while maintaining hypersonic speed. The vehicle can change altitude, adjust course laterally, and execute unpredictable zigzag patterns that confound tracking systems designed for conventional missiles. The physics behind this capability are remarkable. Traditional ballistic missiles peak at high altitudes before descending toward their targets, spending much of their flight in space where they're vulnerable to interception. The DFZF operates differently, gliding through the atmosphere at altitudes between 40 and 100 kilometers. This keeps it below most satellite-based detection systems while remaining above the effective range of terminal phase interceptors. Speed compounds the challenge. At Mach 5, the DFZF travels approximately 1 mile per second. At Mach 10, it covers nearly 2 miles every second. Traditional air defense systems struggle to track objects moving this fast, let alone calculate intercept solutions for targets that maneuver unpredictably. Section 2. America's Defense Dilemma. The United States has invested over $200 billion in ballistic missile defense since the 1980s. That entire infrastructure is now threatened by a weapon that costs a fraction to produce. China's hypersonic capability exposes fundamental flaws in America's defense strategy that may take decades to address. America's missile defense architecture operates on the principle of intercept during different flight phases. Terminal high-altitude area defense systems engage missiles during their terminal descent. Aegis destroyers intercept them during mid-course flight. Ground-based interceptors target missiles during boost phase. This layered approach works against traditional ballistic missiles following predictable paths. Hypersonic glide vehicles render this entire approach obsolete. During boost phase, when the DF-17 rocket launches the glide vehicle into the atmosphere, interception is theoretically possible. But China launches these systems from mobile platforms deep within its territory, far from US interceptor bases. By the time American systems detect the launch, the boost phase is over and the glide vehicle has separated. During the glide phase, traditional mid-course interceptors are useless. These systems are designed to hit targets in space following ballistic trajectories. The DFZF glides through the atmosphere, maneuvering continuously. Mid-course interceptors can't reach targets flying below their minimum intercept altitude, and even if they could, they lack the maneuverability to track evasive targets. Terminal phase interception faces even worse challenges. THAAD and Patriot systems rely on predicting where an incoming missile will be seconds into the future based on its current trajectory. When targets change course unpredictably every few seconds, prediction algorithms fail. By the time the system recalculates an intercept solution, the target has moved again. The speed differential creates additional problems. The 2021 test particularly alarmed American planners because it demonstrated China's ability to launch hypersonic weapons via fractional orbital bombardment. The DFZF entered low Earth orbit before descending toward its target, approaching from the south where America's missile defense radar coverage is weakest. This capability allows China to attack targets in the continental United States from unexpected directions, further complicating defense. Section 3. The strategic implications. China's hypersonic capability fundamentally alters the strategic balance between the United States and China in multiple domains. The immediate impact affects Taiwan, the flashpoint most likely to trigger direct conflict between the two powers. China's ability to strike US bases and carrier groups with weapons that can't be intercepted changes the calculus of any military intervention. If conflict erupts over Taiwan, the United States would need to project massive military power into the region quickly. American strategy relies on forward deployed forces at bases in Japan, South Korea, and Guam, supported by carrier strike groups operating in the Western Pacific. These assets are now vulnerable to precision strikes from hypersonic weapons that arrive with minimal warning. Consider a scenario where China launches simultaneous strikes against Kadena Air Base in Okinawa, Andersen Air Force Base in Guam, and US aircraft carriers operating near Taiwan. DF-17 missiles carrying DFZF glide vehicles launch from mobile platforms throughout mainland China. Within minutes, hypersonic weapons are descending on their targets, maneuvering to avoid any defensive fire. American forces would have almost no time to react. By the time radar detects the incoming weapons, they're already in terminal phase. Patriot batteries fire desperately, but the hypersonic glide vehicles maneuver around interceptors. Hypersonic glide vehicles change that equation. Now, China can deliver nuclear weapons against targets in the continental United States with high confidence that defenses cannot stop them. Section 4. The race for countermeasures. The Pentagon is scrambling to develop responses to China's hypersonic advantage, but solutions remain years away at best. Current efforts focus on three main approaches: new interceptor technologies, improved detection systems, and development of American hypersonic weapons to restore strategic balance. The most ambitious interceptor program is the Glide Phase Interceptor, being developed by Northrop Grumman and Lockheed Martin. This system is specifically designed to engage hypersonic glide vehicles during their atmospheric flight phase. Unlike traditional interceptors that follow ballistic paths, the GPI will maneuver continuously, matching the target's evasive actions. Technical challenges are immense. The GPI must accelerate to hypersonic speeds, sustain flight in the atmosphere while maneuvering, and maintain sufficient fuel reserves to pursue targets that zigzag unpredictably. The system requires advanced materials that can withstand extreme temperatures without degrading. Guidance systems must process targeting data and adjust flight paths faster than current technology allows. Even if technical hurdles are overcome, deployment timelines extend well into the 2030s. The program only reached the design phase in 2022. Prototypes won't fly until 2027 at earliest. Testing and refinement could take another 5 years. Operational deployment might occur around 2035, assuming no major setbacks. By then, China will have deployed hundreds of hypersonic weapons and developed countermeasures against American interceptors. Detection improvements offer more immediate promise. The Space Development Agency is deploying a constellation of hundreds of small satellites designed to track hypersonic weapons continuously from launch through impact. These satellites use infrared sensors that detect the heat signatures generated by atmospheric friction during hypersonic flight. Unlike traditional missile warning satellites that spot launches, this system maintains constant tracking, The Hypersonic and Ballistic Tracking Space Sensor constellation aims to provide real-time tracking data to missile defense systems, enabling faster response times. If sensors can detect hypersonic weapons immediately upon launch and maintain continuous tracking throughout their flight, defensive systems might have sufficient warning to attempt interception. The first satellites deployed in 2023, with full constellation operational capability expected by 2030. Directed energy weapons represent a potential game-changer. High-energy lasers traveling at the speed of light could theoretically engage hypersonic targets that missiles cannot intercept. The challenge lies in generating sufficient power to destroy hardened targets at useful ranges. Current laser systems produce around 300 kilowatts, enough to disable drones and small missiles, but insufficient against hypersonic glide vehicles. The Pentagon is funding research into megawatt-class laser systems that could engage hypersonic weapons. These systems would be mounted on ships, aircraft, or ground installations, creating defensive bubbles around critical assets. Technical obstacles include power generation, thermal management, and beam control over long distances through atmospheric turbulence. Operational systems probably won't exist before 2040. America's own hypersonic weapons development aims to restore deterrence through assured retaliation capability. If China can strike American targets with hypersonic weapons, the United States must possess equivalent capabilities to threaten Chinese assets. This creates a balance of terror similar to mutually assured destruction during the Cold War. The AGM-183 air-launched rapid response weapon was America's most promising hypersonic program. Designed to travel at Mach 20 and maneuver unpredictably like China's DFZF, the ARRW would have provided U.S. forces with similar strike capabilities. However, the program was cancelled in 2023 after multiple test failures and cost overruns exceeding $14 million per missile. Alternative programs continue. DARPA's Operational Fires program is developing a ground-launched hypersonic weapon. The Navy's Conventional Prompt Strike Missile will arm surface ships and submarines with hypersonic capability. The Air Force is exploring scramjet-powered missiles using rotating detonation engine technology that could achieve even higher speeds than China's current systems. None of these programs will field operational weapons before 2027, and many face the same technical challenges that doomed the ARRW hypersonic flight generates extreme temperatures that degrade materials. Control systems must function at speeds where millisecond delays mean missing targets by miles. Costs remain astronomical, limiting procurement even if technical problems are solved. China's DFZF hypersonic glide vehicle can strike targets anywhere in the Western Pacific in minutes, while evading every missile defense system America deploys. The weapon turns radar screens into chaos as it zigzags unpredictably at Mach 10, arriving before defenders can react. The question is, can the United States develop effective countermeasures before China's hypersonic advantage becomes insurmountable? Or has the strategic balance already shifted permanently in Beijing's favor? Drop your thoughts in the comments. And if you want more analysis of weapon systems reshaping global military power, make sure you're subscribed. Thanks for watching.